In our tech-driven world where computers play an increasingly prominent role, programming has become an essential skill. Whether you want to build a website, create an app, or simply understand how software works, learning to program is the first step. In this video, we'll cover the basics of programming, giving you the foundation you need to get started. So, let's dive in. First, let's clarify what programming is and how it differs from coding. The terms programming and coding are often used interchangeably, but there are subtle differences between them. Programming refers to the comprehensive process of creating software. It encompasses everything from planning and designing to coding and testing. Programmers are responsible for conceptualizing the logic of a program, designing its structure, and solving complex problems. They focus on creating algorithms and workflows that guide the software's behavior and ensure it meets the specified requirements. Coding, on the other hand, is a specific part of the programming process. It involves writing the actual lines of code using a programming language to implement the design and functionality envisioned by the programmer. Coders translate the logical solutions and algorithms into a syntax that the computer can execute. In essence, programming is like constructing a building where you start with an architectural plan and oversee the entire construction process. Coding is akin to laying the bricks according to the blueprint. Both are crucial, but programming encompasses a broader scope that includes coding along with other essential tasks like debugging, testing, and optimization. Now, let's see why you should learn to program. Learning programming is an invaluable skill in today's world. It not only opens up a wide range of career opportunities in various industries, such as software development, data analysis, and cybersecurity, but also enhances problem-solving and logical thinking abilities. Programming empowers individuals to create their own applications, automate tasks, and bring innovative ideas to life. Additionally, understanding programming fosters a deeper comprehension of how technology works, making one more adept at navigating and leveraging digital tools in everyday life. Whether you're looking to advance your career, develop new skills, or simply challenge yourself intellectually, learning programming offers numerous benefits and can be a highly rewarding endeavor. Next, let's explore some basic concepts that are common across all programming languages. As you may know, there are many programming languages, each designed for various purposes and applications. Some of the most commonly used ones are Java, C++, Python, JavaScript, and C#. While each language has its own unique syntax and rules, they all share several fundamental concepts. These include variables, loops, conditionals, functions, and classes, among others. Let's take a closer look at these key concepts. Variables are basic elements in programming that store data values which can be used and manipulated throughout a program. They act as placeholders or containers for information, such as numbers, text, or other data types. By assigning a name to a variable, programmers can easily reference and update the stored value as needed. For example, in many programming languages, you might declare a variable with a statement like age equals 25, which assigns the value 25 to the variable named age. This makes it easy to manage and use data dynamically within a program. Some languages also require the programmer to explicitly set the data type of a variable. In this case, that would be integer. So in languages like Java or C++, you would write int age equals 25. Depending on the data type, you might also want to perform other operations on variables such as incrementation and negation. For example, in Python, we can write age equals age plus 5, which would increase the value of the variable age by 5. Next, we have loops. Loops are essential structures in programming that allow for the repeated execution of a block of code as long as a specified condition is met. They are used to automate repetitive tasks, making code more efficient and easier to manage. The two most common types of loops are the for loop, which iterates a set number of times, and the while loop, which continues until a certain condition is no longer true. For example, in Python, a loop might look like this: for I, in range 5, print I, which would print the numbers 0 through 4. Loops help in managing tasks that require iteration, such as processing items in a list or performing actions until a particular state is achieved. Up next, we have conditionals. Conditionals are a fundamental concept in programming that allow code to make decisions based on specific conditions. They enable a program to execute certain blocks of code only if a given condition is true. The most common conditional statements are if, else if, and else. For example, in Python, an if statement might look like this. If age greater than or equal to 18, print, you are an adult. This code checks if the variable age is 18 or greater, and if so, it executes the print statement. Conditionals are crucial for creating dynamic and responsive programs that can handle different scenarios and inputs effectively. Next, we have functions. Functions are reusable blocks of code in programming that perform specific tasks or calculations. They allow programmers to organize code into modular, manageable sections, promoting code reuse and reducing redundancy. A function typically includes a name, parameters, and a body of code that executes when the function is called. For example, in Python, a simple function might look like this: defgreet, name, print hello plus name. This function, greet, takes a parameter name and prints a greeting. By using functions, programmers can write cleaner, more efficient code that is easier to test, debug, and maintain. And lastly, let's take a look at classes. Classes are a fundamental concept in object-oriented programming that allow programmers to create custom data types by bundling related properties and methods into a single blueprint. A class defines the structure and behavior of objects which are instances of the class. For example, in Python, a class for a car might look like this. This class includes attributes like make and model and a method to display information. An instance of this class could be created with my car equals car, Toyota, Camry. By using classes, programmers can model real-world entities and their interactions, promoting code reuse and organization. This concludes our exploration of the basics of programming. If you enjoyed, consider subscribing.